Welcome to This Explainer. Today, we're popping the hood and taking a good hard look at the actual foundation of Google Cloud Platform, specifically compute and storage. Now, if you've been around the tech block, you know modern infrastructure is way more than just, plugging in a few servers. So we're going to unpack the real building blocks of GCP and see how its processing and storage systems actually tick when they're operating at scale.
But before we get into the weeds, I want you to think about this central question. What exactly makes up the foundation of the cloud? Seriously, grasping this is the literal difference between just blindly renting servers and actually architecting a scalable, optimized, and cost-effective masterpiece. Underneath all that marketing fluff, cloud computing relies on some very distinct, highly organized pillars. And our goal today? To put those concrete elements under a microscope and figure out exactly how Google puts them together.
Okay, let's dive into this. Here's our roadmap for today. First, an intro to Google Cloud Platform. Second, compute engine. Third, cloud storage. And finally, taking control with Cloud Shell.
Section 1. Intro to Google Cloud Platform. Laying the groundwork.
You know, every massive skyscraper needs a solid foundation, right? Well, your journey into cloud architecture starts with this vital triad: data products, technology, and usage scenarios. Learning GCP is never about looking at isolated tools in a vacuum. The absolute best cloud architects, they always start with the usage scenario. Like, let's say you're building the backend for a real-time mobile app. That specific scenario dictates the tech you need. Maybe you need microsecond latency or maybe global scalability. And then that technological need points you directly to a specific data product, like Cloud Spanner or BigQuery. It all just depends on whether you need strict relational consistency or massive heavy-duty analytical processing. The whole platform is literally designed so that real-world problems dictate your tech choices, not the other way around.
Let's move to Section 2 and see how this builds. Compute engine, CPUs on demand, the brains of the operation.
So Compute Engine is GCP's infrastructure as a service offering for running your virtual machines. And the beauty here is that instead of being locked into those rigid old-school server configurations, Compute Engine gives you CPUs on demand with a frankly incredible degree of flexibility. Google actually lets you use custom machine types. This means you can mix and match the exact ratio of virtual CPUs and memory you need for your specific workload. No more overpaying for some pre-packaged, oversized tier. Plus, it runs on per-second billing, so you are literally only paying for the precise compute cycles you actually use. Add in some incredibly cool features like live migration, where Google can actually move your running VM to a totally different physical host during maintenance without any downtime, and you've got yourself a rock-solid, completely customizable processing foundation.
Moving right along to Section 3. Cloud storage, a global file system. The Vault.
Now, what's really interesting here is that cloud storage in GCP operates entirely differently from, say, your standard local hard drive or block storage attached to a specific server. It is essentially this infinitely scalable object storage system. When we call it a global file system, we mean you can just toss your unstructured data. We're talking everything from video files to massive sprawling data sets into these buckets that can be made available globally. Because it's object storage, you aren't sitting there stressing over file hierarchies or worrying about running out of disk space. Google handles all that underlying capacity and replication for you behind the scenes. They offer different storage classes too, from standard for data you hit all the time to cold line and archive for those long-term backups. And get this, it maintains a staggering 11 nines of durability. Your data is incredibly redundant, highly available, and instantly accessible from basically anywhere on the planet.
And this brilliantly illustrates the dynamic between the two. To really get the most out of the cloud, you need this seamless synergy between processing and storage. Imagine you're setting up an automated data pipeline, right? You could have a compute engine virtual machine temporarily spin up just to yank a massive raw dataset out of a cloud storage bucket. The VM processes that data entirely in memory. Maybe it's applying a complex machine learning model or running a huge transformation. Then, once the heavy lifting is done, it writes that beautifully refined output directly back into cloud storage as a brand new object, and then the VM just terminates itself to save you money. It's like a perfectly choreographed dance. One active engine dynamically crunching the numbers, and one vast passive vault holding the state. They interact continuously, and that right there is the backbone of almost any major cloud application.
Which brings us to Section 4, taking control with Cloud Shell, the control room.
Okay, so Cloud Shell is an absolute game changer. It's a browser-based, interactive shell environment that fundamentally flips how you interact with your infrastructure. Think about it. Instead of wasting hours installing SDKs, fighting with authentication configs, and setting up command line tools locally on your own laptop, Cloud Shell just hands you a temporary, Debian-based virtual machine directly inside the GCP console. It is completely preloaded with the heavy hitters, things like gcloud, kubectl, Python, Node.js, you name it. It even gives you a persistent 5 GB home directory so your scripts and config files don't just vanish between sessions. And since you're already logged into the console, your authorization is handled automatically. It's just immediate, secure access to manage all your compute and storage resources from any browser on any device.
So the crucial point is how all of this connects into a really powerful, practical workflow. Let's say you need to host a dynamic, media-heavy web app. That's your usage scenario, right? To actually execute this, you just open up Cloud Shell right there in your browser. Using a few quick gcloud commands, you spin up a web server on a customized Compute Engine instance that is tailored exactly to your expected traffic. At the exact same time, you provision a cloud storage bucket to house all those massive media assets, which guarantees fast, global delivery to your users without dragging down your main web server. The entire lifecycle, from that very first architectural decision right through to deploying your processing and storage resources, is managed incredibly swiftly through that pre-configured Cloud Shell environment. It's practically magic.
Well, we've successfully mapped out the foundational blueprint of Google Cloud Compute and Storage. You now see exactly how usage scenarios dictate your tech choices. You know the mechanics of customizing VMs with Compute Engine, the sheer scalable reality of object storage with Cloud Storage, and how to wield all that power instantly via Cloud Shell. And just remember, the infrastructure backing massive services like YouTube and Google Search, it operates on these exact same foundational principles. So now that you have the keys to on-demand CPUs and globally distributed storage, what will you build? I highly encourage you to log into the console today, fire up Cloud Shell, and just start deploying. Thanks so much for joining me for this explainer.